All right, so here we're going to start with the first one. Basically, the steps are you want to isolate the radical on one side of the equation, okay? It's ideal if you can get only one radical on the left side and one on the right side if you have two, okay? Raise each side of the equation to a power equal to the index, okay? And then solve the polynomial equation and check your results. So let's just go ahead with the first one. The first one here is the square root of y minus 1 minus 5 is equal to 5. So first I want to isolate this radical here. To do that, I'm going to add 1 to both sides. So I get that the square root of y minus 1 is equal to 6, right? Now, if there is a square root here, what is the index here? 2. So you raise this to the power of 2 and you raise this to the power of 2. And when you square a square root, they go away. So you have y minus 1 equal to 36. Y equals 37. Okay? Now, you need to check to make sure that that works. All right, you plug it back into here. So now, the square root of 37 minus 1 minus 5, is that equal to 5? All right, that's how I write it. Oh, sorry, minus 1. So 37 minus 1, that's the square root of 36. So 6 minus 1, that is equal to 5. So that's a solution, and I keep that solution. Yeah. Right. Yeah. Okay, so if it doesn't work, you cross out the answer that doesn't work. All right? So you could get one solution, more than one solution, or no solution. So in this case, if this one didn't work, we would have said no solution. All right, let's do this next one. So this one here, right, I have a radical here and a radical here. It's best if you have one on either side. Like the other one works too. This one is just a little bit simpler. Now, this 2 here, right, you only have a constant appear one time. So I just leave it that way because it doesn't make sense. If I add it to this side, then I'm just going to have a constant on that side. So I just leave it. Can you add x to both sides? Well, you can, but I said it's better if you have it just on like one on each side. It's less complicated with the math. Okay? So just leave it that way. Now I'm going to square both sides. Okay? And here's where we need to be a little bit careful. On the left-hand side here, it's just the square root squared. So I'm just going to get x minus 12 equals. Now here, I have two terms squared, a minus b squared. So remember, you square the first, you square the last, and then the middle term, you have to have a middle term as well. So let's do that shortcut. Square the first, you get 4. Square the last, you get positive x. The middle term is 2 times this times this. So 2 times negative root x, negative 2 root x times 2, negative 4 root x. Okay? Should we review that a little bit? We're good? Okay, now I need to combine like terms. Look, I still have a radical here. Let me combine like terms. Let me subtract x from both sides. Okay? Luckily, those all go away. So I have negative 12 equals 4 minus 4 root x. What can I do now? Subtract 4. Negative 16 is equal to negative 4 root x. What else can I do? Divide by negative 4. So 4 is equal to root x. What now? Square both sides. So x is 16. Okay, well, let's see if that works. Let's check. The square root of 16 minus 12, is that equal to 2 minus root 16? Oh my, what's going on? Okay, so what's this? 4 root 4. Is that equal to 2 minus 4? Is it? No. That means that doesn't work, so it's no solution. Okay? Okay, so let's do this next one. What do I do with the, what do I do first for this next one? Subtract 1. And now I get 3n plus 2 to the power of 1/3 is equal to negative 1. Now, here I have to the power of 1/3. I want to make that go away. I want to make that an exponent of 1. So what do you think, Ariella? Right, you don't, right, so we don't say multiply, but we raise it to the power of 2/3. And raise this to the power of 2/3. Oh, no, I'm sorry. No, not 2/3. 3/1. You have to do the reciprocal.
When do we know to do the reciprocal and when do we have to fill it in?
Okay, so you fill it in when you're rationalizing. That was a completely different thing. Here you have to do the reciprocal. Okay?
Okay.
So now 3n plus 2 is equal to negative 1 cubed. So 3n plus 2 is equal to negative 1. Yeah.
Could you also maybe do a little 3n plus 2?
You can, and then you still have to,
Yeah, 'cause I was doing
right, you still have to cube it then. Yeah.
So you get n equals negative.
Yeah, 3n equals negative 3, so n equals negative 1. Okay? All right. Questions? Questions on this? Okay, so now go ahead and check and let me know if that works. When you check, it does work, so the answer is n equals negative 1. All right, let's do this next one. What can I do for this next one? Add 2 first. So I have 3 times 5y minus 1 to the power of 1/3 is equal to 2. Now what? Divide by 3 first, right? First make that 3 go away. So I have 5y minus 1 to the power of 1/3 is equal to 2/3. Now what do I do? Right, cube both sides. Okay, here I have 5y minus 1 is equal to, who does that cube belong to? Both of them. So 2 cubed is 8, 3 cubed is 27. Now what am I going to do? Add 1. So 5y is equal to, okay, so remember my shortcut with fractions and a whole number? The denominator is going to be the same. So now I do a loop. 27 times 1 is 27. Plus 8, 35. Okay, so times and then add the 2, whatever you get. 35/27. Now what am I going to do? Times 1/5 or divide by 5. So y is 7/27. Okay? Right, and then check. So now, here is what I'm going to tell you. Okay? Let's think about this for a minute. If you have the square root of something, or if you have the fourth root of something, right? Can x be any number you want? Can it? Can x be 0? Here, in root x, can x be 0? No?
I mean, is it equal to something?
No, if I just have a square root, okay? What number can I put inside? Can I put a 0 inside?
Yeah.
Can I put a positive number like a 10 inside?
Yeah.
Can I put a negative 10 inside? No, right? Can you have the square root of negative 10? No. Well, what if you have a cube root? Can I have a positive number in here?
Yes.
Yeah.
Can I have a negative number in here?
Yes.
Yes, right? Okay, so cube roots don't have that restriction of it has to be positive or else, or 0. Square roots do. So when in your problem, when you have an even root like this, always check. You might have extraneous solutions. But if you have an odd root to the power of 1/3, or the cube root, or the fifth root, you can check, but they're all going to work. There is no restriction. Okay? All right. Now, let's move on to radical inequalities. Yeah. So what I was saying is, take a look at what's different here. Instead of the equal sign, you have an inequality. We're going to solve it the same way, except there is one thing that we're going to add. And what we're going to add is this. If the index of the root is even, identify the values for which the radicand is non-negative. So there is one extra step that we're going to add. For now, let's solve this as if it was a regular old equality like we were solving here. Let's just do that, okay? So I'm going to take this equation, and you know what? I'm just going to solve it. So subtract 4, and now I have the square root of this less than or equal to 3. Is that right?
Yes.
Now I'm going to square both sides, right? So I get 3x minus 6 less than or equal to 9. Now what? Add 6. So 3x less than or equal to 15. X is less than or equal to 5. Is that right?
Yeah.
Okay. But because this is an inequality, there is an added component. The added component is this thing inside can never be negative, right? You can never have the square root of a negative number. So now, here I'm saying x can be anything less than or equal to 5. Does that work? Let's look at this on a number line. Here is 5, and now we're saying anything below 5 is a solution. Anything below 5 works, guys. So look at here, x equals 0. Can x be 0 for this equation? What if x was 0? What would you get? You would get the square root of negative 6, right? And there are so many other numbers that won't work because you'll get the square root of a negative number. So the added extra step is this. You take the radicand. The radicand is the stuff inside the radical. Okay? The stuff inside the radical must always be greater than 0. Okay? Minus 6 is greater than or equal to 0. Now let's solve this. 3x greater than or equal to 6. X is greater than or equal to 2. Now I need to combine these two. So let's see what this looks like. My purple says x has to be less than or equal to 5. That's this. Correct? My red says x has to be greater than or equal to 2. Where is the region where both of them work? 2 to 5. So your final answer will be 2 to 5. Okay? It's super, super important that these inequalities in the blue are pointing the right way. Okay? That's how it needs to look, period. If it's a region that's bound between two numbers, that's how it's going to look. That's the direction. Okay, one question and then I'm going to move on. Yes?
May you draw a number line?
No, you don't have to. It helps. Okay, so I'm going to subtract 1. So the square root of 2x plus 2 is greater than or equal to 4. Now I square both sides. 2x plus 2 is greater than or equal to 16. 2x greater than 14. X is greater than or equal to 7. Okay, now part 2. I take the inside only. And I say that has to be what? Greater than or equal to 0. Now look at what happens. It's kind of cool. 2x is greater than or equal to negative 2. Okay. And then what? X is greater than or equal to negative 1. Okay? Now, this is an exception. So look at what happens. This is negative 1, 0, and we'll say that that's 7. Okay, take a look. My purple says x is greater than or equal to 7. My red says x is greater than or equal to negative 1. Where is the region that both of them match? 7 and above, right? So your solution will be x is greater than or equal to 7. Okay? Okay, this one. I'm going to add 2. So the square root is less than 0. 2. 6. Square both sides. 4x minus 4 is less than 36. 4x is less than 40. X is less than 10. I take the 4x minus 4. And now I'm just going to do greater than 0, not greater than or equal to. 4x is greater than 4. X is greater than 1. Huh? No, because conceptually, you want the stuff inside, the integrand inside, to be positive, which means greater than 0. Yeah? Okay, so number line. Here's 1. Here's 10. So my purple says it has to be less than 10. My red says it has to be greater than 1. If it's between two numbers, right, then it goes 1 to 10, okay? And then the inside always looks the same. Less than x less than. Okay? So that's this one. Any questions on C? Okay. This one, the homework, it says 23 to 59 odd. I'm going to reduce it a little bit. I'm going to make it every other odd. Right? You guys know how that works? So you start with 23. Whoops. You start with 23. You skip 25. You go to 27. You skip 29. You go to 31. Okay? A high risk of making a mistake on like the numbers. Sometimes like students just like they're off one and then they do like the wrong homework for all of them. Okay? All right. So let me pause this.